This video is going to be dealing with Boyle's law. And Boyle's law deals with the relationship between pressure and volume. So, with Boyle's law, the equation is P1 times V1 equals P2 times V2. And this just simply means that for a given situation, one, the initial situation, you have a given volume and a given pressure. And if you change one of those variables to a final pressure, a final volume, the other variable is going to change as well. The relationship between pressure and volume is inverse. So pressure is inversely related to volume. That simply means as one goes up, so if pressure goes up, volume is going to go down. So take, for instance, say I have molecules floating all around, or they're moving all around inside of a container. So each molecule is moving a set speed based on the temperature of the container. So here's my container. Now, the pressure is going to be defined by how often a molecule hits the outside of the container. The more frequent the molecule hits the outside of the container, the higher the pressure. So, with Boyle's law, say we decrease the volume of our container. So here I'm going to draw a smaller box. I'm going to keep the same amount of molecules in my container. And we're going to see what happens to the frequency that they hit the outside of the container. So, if my molecules are moving the same speed because the temperature remains constant and my volume decreases, I can see that the molecules inside this container are going to hit the sides of the container far more frequently than this one. So, here, because my volume decreased, my pressure is going to increase. So let's take a look at a problem, a word problem that deals with Boyle's law. Here we have a sample of oxygen that has a volume of 150 milliliters when it's at a pressure of 0.947 atm. What will the final volume of the gas be at a pressure of 0.987 atm if the temperature remains constant? So here we have our first volume, we have our first or our initial pressure, and we have a final pressure. Now if you notice, the final pressure goes up. So the question is, what's going to happen to our volume as we increase our pressure? So I would always suggest writing out your variables. So we have P1, V1, P2, V2. Pressure 1 is going to be 0.947 atm. Volume 1 is going to be 150.0 milliliters. Pressure 2 is going to be 0.987 atm. And volume 2 is what we're trying to find. So, if we recall, our equation is going to be P1 times V1 equals P2 times V2. Okay, so let's plug in. So, pressure 1 equals 0.947 atm. We're going to multiply that by volume 1, which is 150.0 milliliters. All this is going to be equal to our pressure 2, 0.987 atm, times our V2. And we're just going to solve for V2 algebraically. So I'm going to divide both sides by 0.987 atm. Divide both sides by 0.987 atm. Now if you notice, my units of atm cancel out. I'm left with units of milliliters. Over here, my 0.987 cancels out 0.987 atm. I'm left with V2. When calculating, have 0.947 times 150 divided by 0.987. I end up getting V2 equaling 143.9 milliliters.